Computers are classified based on size, data processing capabilities, computer generations, and purpose. Now, first we look at classification of computers based on size or capacity. Based on size of capacity, the computers are classified as supercomputers, mainframes, mini computers, microcomputers, which are also PCs. Now, let us look at supercomputer. Supercomputer is a multi-user, most powerful and fastest computer. It is quite expensive, mostly used by scientists and engineers. Example of a supercomputer is Fugaku supercomputer, and there are other supercomputers. Mainframe. Mainframe is powerful than mini computer. It is a multi-processing computer and processing is quite fast. It is also a multi-user computer, so multiple users can be connected. It solves complex calculations and works for long periods of time. It is used by large organizations. Example of mainframe is IBM Z series mainframe computer, UNIVAC, etc. Based on size or capacity, the next is mini computer. Mini computer is a digital multiprocessing and multi-user computer. It is powerful than microcomputer. Used in small business applications. Example of mini computer is PDP-11, and there are other examples. Microcomputer is also called a PC or personal computer. It is a single user computer. It is a small computer and less expensive. And microcomputers can be desktop computers, laptops, smartphones, tablet or workstation. Workstation is nothing but single use computer connected to network. And PC is used to process everyday tasks. Now let us look into classification of computers based on data processing capabilities. Based on data processing capabilities, computers are classified as analog computers, digital computers, or hybrid computers. So computers based on data processing is here analog, digital, and hybrid computer. Now let us look at details of analog computer. It measures physical quantities like temperature and distance. It is quite fast. Accepts input in analog form. Used in scientific and engineering fields. Example of analog computer is speedometer, voltmeter, etc. Next, based on data processing capabilities is digital computer. It accepts input in digital form. It is based on binary digits 0 and 1. Performs calculations and logical operations. It is slower than analog computers but more accurate and reliable. Example, laptops, desktops, smartphones, tablets, etc. All these are digital computers. Hybrid computer. It has both the characteristics of analog and digital computers. So the characteristic of analog computer is the speed. So it has both characteristics of the speed of analog computers and the accuracy of digital computers. Solves complex problems quickly. Example, electrocardiogram, ECG, ultrasound machine, and fuel vending machine at gas station. Now let us look at classification of computers based on computer generations. There are 5 generations in computers. Based on the generations, computers are classified into 5 generations. 1, 2, 3, 4, 5. We'll look into each of these generations and what has been developed in each of these generations. First generation of computers are vacuum tube based and were in the years 1940s and 1950s. The second generation of computers are transistor and diode based and were in the years 1950s and 1960s. Third generation of computers are integrated circuit based, IC based, and were in the years 1960s and 70s. Fourth generation of computers are microprocessor based and were in the years 1970s to the present. Still we have these microprocessors. Fifth generation computers are artificial intelligence based and were in the present, and the future is also artificial intelligence. The next classification is classification of computers based on purpose. Based on purpose, computers are classified into general and special purposes. So there are general purpose computers and special purpose computers. We'll look into each of these. General purpose computers. General purpose computers are used in everyday tasks like word processing, etc. And they are less expensive and limited capacity. Examples are laptops, desktops, smartphones, tablets, etc., which we use in everyday life. Special purpose computers. These are used to perform a special task like weather forecasting. They are most expensive and has higher capacity. Example, ATMs, washing machines, etc. Computer memory. Let us just see the hierarchy of the computer memory. Later, we'll discuss in detail about each of these in the coming sections. Computer memory is basically divided into primary memory, secondary memory, and cache memory. Primary memory can either be non-volatile or volatile. The non-volatile primary memory is ROM, that is read-only memory, PROM, programmable read-only memory, EPROM, that is erasable programmable read-only memory, and EEPROM, that is electrically erasable programmable read-only memory. Volatile memory can be SRAM or DRAM. SRAM is static random access memory and DRAM is dynamic random access memory. So the normal RAM we talk about is this DRAM. Secondary memory is divided into either fixed storage or removable storage. The fixed storage secondary memory is HDD, that is hard disk drive, or SSD, that is solid state drive. And removable storage can be divided into optical disks, that is like DVDs, CDs, memory cards, floppy disks, magnetic tapes. Now let us look into non-volatile primary memory. Non-volatile primary memory can be read-only memory. So, in case of read-only memory, the data cannot be electronically modified after the manufacture. It can be PROM, that is programmable read-only memory. So in case of programmable read-only memory, they are sold blank and programmable by user. The contents can be changed once after the manufacture. They can only be changed only one time after the manufacture. And EPROM, erasable programmable read-only memory. It can be reprogrammed, but the chips has to be removed from the device. The data can be erased by exposing to strong ultraviolet light. In case of EEPROM, that is electrically erasable programmable read-only memory, it can be erased electrically and reprogrammed without removing chips from the device. And it can be erased certain number of times. Now, let us look into volatile primary memory. Volatile primary memory is static RAM, that is static random access memory. In this static random access memory, data is retained as long as it has power. There is no need to refresh. It is faster but expensive. Used for cache and internal registers of CPU. Dynamic random access memory. It is used for processing of data and program code. This is the main memory. It has to be refreshed frequently and it is inexpensive than SRAM and it is slower than SRAM. Now let us look at fixed storage secondary memory. What comprises of fixed storage secondary memory? Hard disk drives. Hard disk drive stores and retrieves data using magnetic storage. Data is accessed in random access manner. Hard disk drives are non-volatile based on read-write head and spinning disks. Solid state drives. SSDs are non-volatile. It has no moving parts. It is faster, reliable, noiseless, and consumes less power. Now let us look into removable storage secondary memory. There's optical discs. Optical discs are compact discs that are CDs, DVDs that are digital video discs, and Blu-ray discs. And there will be memory cards in removable storage, and memory cards are used in mobile phones, laptops, digital cameras, etc. Floppy disks are now outdated and USB flash drives mostly replace them. Mostly magnetic tapes are replaced by hard disks. So these are the removable storage secondary memory. Now let us look at cache memory. Cache memory temporarily stores frequently used data and instructions for quick processing by CPU. The CPU first checks the cache, and if the information is not there, then it checks the main memory. It is expensive. Now let us look into measurement. The units of memory are bits, which are the binary digits 0 and 1. 4 bits make a nibble and 8 bits make a byte. 1024 bytes make a kilobyte, 1024 kilobytes make a megabyte, and 1024 megabytes make a gigabyte. 1024 gigabytes make a terabyte, 1024 terabytes make a petabyte. So these are the units of measurements for computer memory, and units of memory are bits, which are binary digits 0 and 1. So that's how you can measure the computer memory. CPU, central processing unit. CPU has got arithmetic logic unit, control unit, and some registers. So these are the basic constituents of a CPU. Arithmetic logic unit will do the arithmetic and logical calculations, and control units will control the CPU, the instructions that are coming to the CPU, and then the registers will store the data and instructions. From the outside world, it will interact with this memory. Let's see the basic features of a CPU. CPU executes the instructions given by a computer program. It performs the following operations. It will perform the arithmetic operations like addition, subtraction, division, multiplication, and it will perform the logical operations and or not, and it will perform the input output operations. Now let us see the parts of CPU in detail. It has got arithmetic logical unit, will do the arithmetic and logical operations. We have seen that. And there are some registers are used for accessing and storing data required, and these registers are the memory address register has the address of memory location to be accessed, and memory data register has the data which is read from the location which memory's address register has, and the instruction register has the instruction to be executed. Whatever the instruction has to be executed on that piece of data, that instruction will be stored in this instruction register. The program counter PC as the address of the memory location for the next instruction. Next is the cache memory. The cache memory temporarily holds the instructions and data required by CPU. It thus helps in processing fast as it saves the time of loading from RAM. The level 1 cache, which is closest to CPU, has the instruction cache L1I and the data cache L1D. Level 2 and 3 caches has the instruction and data that are needed next. The accumulator stores the result of the operation of arithmetic logic unit. The process of fetching instructions, that is locations of data and the data itself, decoding the instruction and executing the instruction is called CPU instruction cycle. That is the process of fetching instructions, decoding the instruction and executing the instruction called the CPU instruction cycle. The CPU instruction cycle is managed by the control unit. The CPU instruction cycle is synchronized by the CPU clock. Buses. The data and signals between the processor and other components are sent by buses. The address bus carries memory addresses from the processor to other components. The data bus carries the data and instructions from the processor to other components. The control bus carries the control signals from the processor to other components. Types of CPU. Single core CPU. Single core CPU can execute one command at a time. Not good for multitasking. Dual core CPU acts like two CPUs, can execute more than one command at a time. Multitasking is possible. Quad core CPU, 4 cores working simultaneously. More multitasking capabilities than dual core CPU. Similarly, hexacore, octa-core and deca-core CPUs are powerful than quad core. History of CPU. Vacuum tubes is the first generation. It is in the years 1940s and 1950s. Next is transistors. That is the second generation in the years 1950s and 1960s. Next is integrated circuits, ICs. That is the third generation. That is in 1960s and 1970s. Next is microprocessors. That is the fourth generation from 1970s to the present time. Next is the artificial intelligence. That will be the fifth generation, and that is from the present to the future. So now currently the present and future we have the artificial intelligence. Currently microprocessors we have still the present conditions. That is the fourth generation. Operating system. The user doesn't directly interact with the hardware. User interacts with the operating system through the programs. The programs may be application programs or system programs, and the operating system interacts with the hardware. So the user doesn't directly interact with the hardware, but the user interacts with the operating system and the operating system interacts with the hardware. Now let us see some features of the operating system. Operating system is a system software that manages the resources. The resources may be hardware, software and applications of the computer. So operating system is a system software that manages the resources of the computer. Whatever the resources may be, operating system manages those resources. Operating system acts as an intermediary between user and computer hardware. The user doesn't directly interact with the computer hardware, but operating system acts as an intermediary between user and computer hardware. The user interacts with the operating system and the operating system interacts with the computer hardware. Operating system loads the application program to memory and allocates it to CPU. Operating system manages the security of the system also. So it manages the system security. Examples of operating system are Microsoft Windows, Macintosh, Unix, Linux, iOS, Android, etc. Now we'll look into how user interacts with the operating system. What are the user interfaces? Ways the user interacts with the operating system. So first of all, it is through graphical user interface, which is also called GUI, with the help of graphics and icons. So the user may click the graphic or icon using their mouse or keyboard and interacts with the operating system. The input devices are mouse and keyboard. Next is through touchscreen GUI. It is the same as GUI, but fingers or stylus is used to operate. Examples are mobile phones. There will be stylus attached to a mobile phone, which you can use to operate the mobile phone, or you can use the fingers to operate the mobile phone. So through touch screen, the user interacts with the operating system. Through command line interface, in this case user has to type instructions. The input device in this case is keyboard. Through voice, example Siri for iPhone and other voice commands for other phones. Now we'll look into functions of operating system. Process management function. Operating system has to manage multiple processes that are running by wisely allocating CPU among processes so that the tasks are completed in minimum time. So when multiple processes are running, the CPU time has to be allocated wisely by the operating system. So this is the process management function that operating system performs so that the tasks are completed in minimum time. Memory management. Operating system has to allocate memory between processes and free memory when not required by a process. So a process may be running and a process may be idle at some point of time. So when the process is idle, then the operating system has to remove the memory from it or free memory from it, and whatever processes are running, the operating system has to allocate memory to those processes. So this management of memory is done by the operating system. And then the security management. Operating system has to see that authorized users access the applications. So when an unauthorized user accesses the application, there will be an issue with the security. So operating system manages this security by using the passwords. Passwords help in performing this function. So operating systems, with the help of the passwords, manages the security so that only authorized users access the applications, whether it's the resources or whether it's the files or whatever the applications has been used will be used only by the authorized users and not by unauthorized users. The next function of the operating system is storage management. Operating system manages storage resources to improve performance. It optimizes storage resources. It helps to protect the data integrity. By optimizing the storage resources, it helps to protect the data integrity. Resource management. Operating system manages the resources between processes. Operating system has to dynamically allocate and deallocate the resources between processes as required. So some processes may be idle and may not require the resources. At that point of time, operating system has to deallocate the resources for that process, and whichever process is running and require the resource, operating system has to dynamically allocate that resource to that process. So this resource management is done by the operating system. Now let us look into the types of operating system. Real-time operating system. The response time is very quick in case of real-time operating system. The input is processed and output given very fast. Time sharing operating system. Multiple tasks get equal opportunity and each user gets CPU time as if using a single system. These are also called multitasking systems. So they share the time of the CPU between multiple processes and manage that CPU time. So this is the time sharing operating system. Batch operating system. The operator groups similar jobs into batches and send to the computer. The operating system does not directly interact with the computer. So it will create batches of the jobs and will be sent to the computer instead of operating system directly interacting with the computer. These batches of jobs will be sent to the computer, so they will interact with the computer. The next type of operating system is distributed operating system. In this type of operating system, various computers which are connected communicate with each other. Remote access is possible in distributed operating system. Network operating system. Many clients are connected to the server and share resources over a private network. So here it's a server client system where many clients are connected to the server and share resources, and it is a private network. Computer software. Computer software is a set of instructions given to a computer to make it work. The lowest level of instructions is machine level instructions. These instructions are in binary values. The instructions written in assembly language can be translated to machine level instructions by assembler. The instructions written in higher level languages can be translated to machine level by compiler or interpreter. Types of software. Computer software can be divided into system software and application software. And system software is again subdivided into operating systems, device drivers, and utility software. We'll look into each of these coming sections. Operating system. Operating system is a subdivision of the system software. So it is the system software that manages resources, whether it's a hardware resource, a software resource, and applications of computer. So any of the resources of the computer, the operating system manages that resource, and it is a part of the system software. An operating system is an intermediary between user and computer hardware. The user doesn't directly interact with the computer hardware, but user interacts with the hardware through operating system. Operating system loads the application program to memory and allocates it to CPU. And operating system manages security of the system. System security is managed by operating system. Examples of operating system are Microsoft Windows, Macintosh, Unix, Linux, iOS, Android, etc. Device driver. Device driver is also a system software. A device driver is a program that controls or operates a particular type of device attached to the computer and enables operating systems and programs to access hardware functions. Device drivers are dependent on hardware. So if multiple devices are attached to the computer, each device will have a device driver. So they are dependent on hardware. So whatever hardware is connected to the computer, a device driver is dependent on that type of hardware. Device drivers are specific to operating system. So Microsoft Windows will have some device drivers, and if it is Unix, there will be different device drivers, etc. So it is specific to a particular operating system. Device drivers communicate through bus or other subsystem. Examples of device drivers are drivers for connecting a printer. So if a printer has to be attached to a computer, a device driver has to be loaded onto the computer so that you can connect the printer to the computer. And device drivers help in communicating with the printer or any other hardware device you connect to the computer. Utility software. Utility software is a type of system software. Utility software is system software that helps in maintenance of computer system. Some utility software is supplied with the operating system. Utility software helps the operating system managing and optimizing the computer system. Now let us look at some examples of utility software. Antivirus. Antivirus helps in protecting the computer from virus. Example of antivirus is Windows Defender. Disk cleaners. Disk cleaners help to free storage space. Example is CC cleaner. Disk defragmenters. Backup utility helps in backing up information on the disk. File management utility manages files. Diagnostic programs checks the status of hardware and software. Network utilities analyzes network connectivity. So these are some of the examples of the utility software, which is a system software. Application software. Another type of software other than system software is application software. It is a software that performs specific tasks other than maintaining the computer. Generally used by users to perform a task or tasks. Examples of application software are Microsoft Word, spreadsheet, video games, Google Chrome, etc. So whatever applications a user uses are all come under application software. Computer hardware refers to physical parts of the computer. They are power supply unit, computer case, internal devices, input devices, output devices, and storage devices. Computer case and power supply. Computer case. Most of the computer components are enclosed in the case. This is mostly for desktop PCs as laptops come with outer housing which protect them. The computer case provides support for the components. It keeps the computer cool. It will reduce the noise. Power supply unit. It converts the alternating current to direct current. It regulates overheating by controlling voltage. Laptops has built-in rechargeable battery. Internal devices. CPU, Central Processing Unit, performs the arithmetic, logical and input-output operations. RAM, Random Access Memory, that has data and instructions used by CPU. ROM, Read-Only Memory, is non-volatile memory that stores software that is rarely changed. For example, BIOS, which boots the computer when switched on. Graphics card, that process computer graphics. Buses, that connect CPU to other internal components. CMOS, that is complementary metal oxide semiconductor battery for CMOS memory. Input devices. Information is provided to the computer through input devices. Keyboard is a text input device. Pointing devices. Mouse is a pointing device moved on a surface. Trackball is like mouse, but a ball is rolled. Touch screen is on computer screen, which is operated by touch. Touchpad is a flat surface on computer operated by moving finger on it. Compound devices. Compound devices, that is having more than two different forms of input. Example, joystick. Joystick is a pivoting stick which is on a base that is stationary. Paddle. Paddle is a game controller having a dial and a button. Gamepad. Gamepad used to play video games. Voice input devices. They capture sound. They are microphones and digital musical instruments. Video input devices. Digital cameras, digital camcorders, webcams, scanners, that is image scanners, fingerprint scanners, barcode reader, eye gaze tracker. Output devices. Output device outputs the information from computer to the user. They are monitors, printers, GPS, projectors, speakers, and headphones. Storage devices. Storage device stores the data and information. RAM, random access memory, that has data and instructions used by the CPU. The cache memory temporarily holds the instructions and data required by the CPU. Hard disk drives, CDs, DVDs, Blu-ray discs, and USBs.